All right, guys, so we're starting to get into polynomials this week. We're going to talk about adding and subtracting polynomials first, and then after we're done with that, we're going to get into multiplying polynomials. But first, before anything, we got to get a couple definitions out of the way, okay? Because I know the word polynomial usually kind of scares people. It's really it's not really a difficult word, anything crazy. It sounds more complicated than it is. A polynomial, okay, is something that has multiple terms. Okay, so that's what we're talking about when we talk about a polynomial. Okay, so for example, 5x to the fourth power plus 2x to the third power minus 9x squared plus 6x minus 7 would be a polynomial that has, whoops, 1, 2, 3, 4, 5 terms in it. So that's a polynomial that has 5 terms. Okay, I like to think of terms as things that are separated by addition and subtraction signs. Okay, so if they're connected, they're considered one term. So this 5x to the fourth is considered one term. This 2x to the third power is considered one term. Terms are separated by addition and subtraction. Okay, so you kind of get the idea there. Going back to the word polynomial, right? Poly means many or multiple, right? A polygon, when you get to geometry, is going to be a figure that has multiple sides. So a quadrilateral, which has 4 sides, is an example of a polygon that has multiple sides. In that case, it has 4. Okay, and then a couple definitions off that, guys. You got monomial. Okay, the prefix mono, right? You ever hear the expression mano a mano? That means one on one. Okay, so a monomial is one term. So, for example, okay, 9y to the sixth power would be a monomial. All right, no pluses, no minuses, just a simple multiplication problem. 8x would be a monomial, one term. Any numbers, guys, any numbers like -6 is a monomial. Okay, binomial, bi, right? Bicycle, 2 wheels. Bilingual, 2 languages. Okay, a binomial has 2 terms. Okay, so for example, 4x minus 6, 2 terms, right? Okay, 1, 2. Okay, 8y to the fourth power plus 17, 2 terms, 1, 2. Okay, I'm hoping you get the idea here. Trinomial, okay, tricycle, 3 wheels, right? Okay, trinomial has 3 terms. Okay, so for example, a trinomial will be something like this: 9a to the second power plus 6a minus 14, right? Okay, count them up. 1, 2, 3 terms. Okay, trinomial. Okay, anything after a trinomial, something with 4 terms, something with 5 terms, so on and so forth. Okay, those don't really have specific names. Okay, so if it had 4 terms in it, that would be a polynomial with 4 terms. Okay, if it had 8 terms, that would be a polynomial with 8 terms. Okay, you get the idea there. All right, degree of a polynomial, we're not really going to talk too much about this, guys. All right, is the highest exponent. Okay, the degree is the highest exponent. So if I looked at this trinomial right there as an example of degree, the degree of that trinomial is going to be 2, because the biggest exponent you see in the problem is 2. If I looked at the first one that I did all the way up here, right, when we talked about polynomial, the biggest exponent there is 4. So the degree of that would equal 4. So the biggest exponent is the degree. Okay. Last thing, descending order, the last definition before we get at some examples, descending order, okay, is when you arrange the polynomial from highest exponent down to the smallest exponent. All right, and you'll really see this when we start doing problems. Descending order is kind of like having a fraction that's unreduced. You want to reduce it. Okay, you always want to reduce your fractions. Okay, when we do these problems, we always want our answers to be in descending order. So, for example, Okay, if you had something like 9y plus 2 plus 6y to the fourth power plus 8y to the fifth power, okay, we wanted to rearrange that in descending order. You find the biggest exponent and you go and you work your way down. So rearrange that, it would be 8y to the fifth, right? That's the biggest exponent. The next biggest exponent is 6y to the fourth. Okay, the next biggest exponent is right here. That has a 1. Okay, so the plus 9y would be next. If there's ever a constant, if there's ever a number, right, also known as a constant, that's always going to be last because it has no variable, which means it has no exponent. So if there's a constant in the expression, a number, that's always going to be last. Okay, so now that when you see these words, guys, okay, now you have an idea what they mean. Now let's talk adding and subtracting. Okay, got a couple problems here for you, pretty basic. Okay, number one is an adding problem. Number two is a subtraction problem. All right, we've talked earlier, guys, about combining like terms. That's really what we're going to be doing here, just with a little bit of a catch. Okay, a little bit of a catch when it comes to subtraction. So we're going to combine like terms. Okay, and with subtraction is just a little bit of a catch. Okay, in number one, it's an addition problem, guys. When there's an addition problem, the parentheses really mean nothing. Okay, they're just separating the polynomials. So you have a trinomial here on the left, right? This would be one trinomial. This would be another trinomial. So number one is an example of adding two trinomials together. Really, all you're doing, guys, is collecting the like terms. Okay, so the 3 and the 4 are going to make a 7. The negative 3b to the second power and the positive 3b to the second power, we actually luck out there. They're going to cancel each other out. Okay, and then the 7b and the 8b are going to make positive 15b. The only thing you have to do once you get your answer is arrange it into descending order if it's not in descending order. So in this one, it's kind of easy. I would just flip-flop the 15b with the 7. So there's an example of an adding problem. Okay, subtraction, okay, remember that subtracting is the same as adding the opposite. Okay, so this is another example. I got a trinomial on the left, I got a trinomial on the right. Okay, subtracting that trinomial is the same thing as adding the opposite. Okay, so really what that means, guys, is I'm going to make this term, and this term the opposite of what they are. Really what you're doing, guys, is you're distributing that negative here, here, and here, and making them all the opposites. You have to do that with subtraction. So the 5r squared becomes minus 5r squared. The positive 6r to the fourth becomes minus 6r to the fourth. The plus 7r cubed become minus 7r cubed. And then after that, everything else stays the same, right? You combine the like terms. So if I was to combine like terms here, you got a 5r to the fourth. That could be combined with the negative 6r to the fourth. That would be negative, whoops, that would be negative 1r to the fourth. Then you can combine the, let's see, well, I got negative 8r to the third, negative 7r to the third. That's going to be negative 15r to the third. And then last but not least, you have a positive 6r squared minus 5r squared, which is going to be positive 1r squared. My answer is in descending order. So you're done. Just a little hint, guys. If you want to make sure that your answer is in descending order, combine the bigger exponents first. So start with the biggest exponent and work your way down. Like in this problem, I started with the r to the fourths, then I went to the r to the thirds, then I went to the r to the seconds. If you do it in that order, your answer is going to finish in descending order. Okay, you won't have to rearrange anything. Okay, last problem, number 3. I got a trinomial added with a trinomial, subtracting a third trinomial. All right, this is not a big deal. Okay, if I rewrote this whole problem out, I have 8x to the fourth down here plus 3x squared minus 8x cubed plus 6x squared minus 7x to the fourth plus 5x to the third. This trinomial and this trinomial don't need to change. The third trinomial is what has to change because you got a minus sign in front of it. So all these terms, those three terms have to change. Their signs have to change. 2x squared becomes minus 2x squared. The 4x cubed becomes minus 4x cubed. And the 7x to the fourth becomes negative 7x to the fourth. Just remember, guys, when I say they change, they don't change to negatives. They change to its opposite. So if I was distributing a negative to a negative, that would actually make it a positive. Okay, now I can start organizing my like terms. If you're smart, you're going to start with the biggest exponent and work your way down. So let's start with the x to the fourths. 8x to the fourth minus 7x to the fourth minus 7x to the fourth. So 8 minus 7 would be negative 1. Negative 1 minus 7 would be negative 8. So I have negative 8 x to the fourth. Okay, now let's go to the x to the thirds. Negative 8x to the third plus 5x to the third minus 4x to the third. Okay, negative 8 plus 5, that's negative 3. Negative 3 minus 4, that's negative 7x to the third. And then it looks like the only thing that I have left are my x squareds. 3x squared plus 6x squared minus 2x squared. 3 plus 6 would be 9. 9 minus 2 would be 7. Positive 7x squared. Your answer is already arranged into descending order because we started with the biggest exponent and worked our way down. Okay, so we don't have to worry about rearranging. So hopefully these strategies that I just gave you help you when you get to the problems that are assigned. Okay, the one thing I want you to be careful of, because we just got done talking about properties of exponents with multiplying and power of a power, power of a product, and the quotient property and all that stuff. This is different. We're combining like terms. When you add things, you're collecting things. The exponents are not going to change. So if you're adding an r to the fourth with another r to the fourth, you're just collecting more r to the fourths. An r to the fourth and an r to the fourth, when you're adding them, don't become r to the eighth, or when we're subtracting them. Okay, the exponents when we add and subtract are going to stay the same. The exponents will change when we get to multiplying problems. We're not there yet. Right now we're just adding or subtracting, obviously. Okay, good luck, guys.